Ever wondered what something like a giant skyscraper, a delicate spiderweb, and even a simple drawing have in common? Well, it turns out they all start with the exact same super simple building blocks. Today, we're going to go right back to the beginning to check out the fundamental ideas of geometry, the stuff that creates basically every shape you see in the world.
You know, whether you're looking at the incredible pose of a dancer or just the strokes of a pen on paper, it all really boils down to the same thing: lines and angles. We're about to break down these core parts and see how everything, from a little doodle to the most massive buildings, is built on this simple foundation.
All right, let's dive in. Our three main building blocks, we're talking points, lines, and angles. They're the bedrock of what's called plane geometry. Just think of it as the geometry you do on flat surfaces. You know, the world of shapes you can actually draw on a piece of paper.
So where do we even begin? With the absolute simplest element you can possibly imagine, a single point. This is the starting block for literally everything else we're going to talk about.
Here's the thing about a point in geometry. It's not really a thing at all. It's more of an idea. It just marks a precise location. Kind of like dropping a pin on a map, right? It tells you exactly where to look, but it has no dimensions of its own. No length, no width, just pure position.
And this is a perfect way to make that abstract idea feel totally real. The sharp tip of a compass, that's a fantastic physical model for a point. It's incredibly precise, marking an exact spot without having any real size.
And you can find this idea all over the place. The tip of a sharpened pencil, the point of a needle, the tiniest dot of ink from your pen, these are all real-world examples that help us picture this very first, very fundamental building block. Okay, so we've got our points. Now what happens when we start connecting them? This is where things start to get really interesting, and we can actually begin building our first shapes. Here's a really simple but kind of perfect analogy. If you take a piece of paper and fold it, the crease you make when you open it back up, well, that's a line segment. Notice how it has a clear beginning and a clear end. It's a real, measurable length.
So, by definition, a line segment is just the shortest possible path between 2 points. And we call those points the endpoints. So this straight path you see here, connecting point A to point B, that's a perfect example of a line segment.
Now let's ask a simple little question that changes absolutely everything. What if that path didn't have endpoints? What if it just kept going? And there you have it. You get a line. By just adding those little arrows to both ends, we've basically turned our finite segment into something infinite. A line has no beginning and no end. It just keeps on going forever, passing right through points A and B on its endless journey.
And that really is the key difference to remember. A line segment is a finite piece that you can measure with 2 distinct endpoints. A line, on the other hand, is this infinite concept that just goes on forever.
All right, let's keep building. What happens if you mash up the idea of a fixed point with the idea of infinity? Well, you get something totally new: a ray. So a ray is this fascinating hybrid. It's got one foot in the finite world with a definite starting point, but the other foot steps off into infinity. It starts at one point and then just keeps going in a single direction forever. Honestly, the best way to think about a ray is to think about light. A beam shooting out from a lighthouse or a flashlight starts at a very specific source, the light bulb, and then travels outwards, seemingly forever, in just one direction. And if you want to think on a cosmic scale, the sun is the ultimate example. Each ray of light starts from a single point, the sun, and then travels outward in a straight path across the universe forever. Pretty wild, right? Okay, so we've got points, lines, line segments, and rays. Now we have all the pieces we need to create one of the most important concepts in all of geometry: the angle. And it's really that simple. You just take 2 rays, make them share the exact same starting point, and that space between them creates an angle. That shared point gets a special name too. We call it the vertex. And the 2 rays, those are the arms of the angle. Let's build one right now in 3 easy steps. First, just place a single point. That's your vertex. Next, draw one ray shooting out from that vertex. And finally, draw a second ray starting from that very same vertex. Boom! The space between them, that's your angle. So how do we measure an angle? Well, it's not about how long its arms are. Remember, those go on forever. It's all about the amount of turn or rotation between them. Think about it like opening a book. A tiny little turn gives you a small angle, and opening it up really wide gives you a large one.
So there we go. From a single, simple dot, we've built lines, rays, and now angles. And these aren't just abstract ideas from a math book, they are literally the alphabet of our visual world. So the next time you look around, I want you to try and see things a little differently. Where can you spot the points, the lines, and the angles that build everything you see?